This is Chapter 6, Part 5 that we're looking into. So Part 5 of the series with it. Let me talk to you about the flow of execution. The execution always begins at the first statement on the top where the function main is. Other functions are executed when it's called. Function prototypes appear right before the function definition with it. So that's how the compiler translates first with it. So in your skeleton, right before your int main parentheses with the function with it, you need to put in a function prototype. Or you can put the entire function, header and body, before that. The compiler can then correct translate the function call with it, if that's the case with it. Function call transfer the control to the first statement of the body's call, the function. When it is called, the function is executed, control is back into the point immediately following the function. So if you look at the void function, this is where it gets really kind of abstract, so I need your attention in this part. Void function is the other function that is not a value function. It does not have a return value, a return statement in this, right? So a user function, user defined, you can also define a void function to be placed inside either before or after the main function, which means that inside the main function, that when you call that function, you can do a cout. You can see what that comes out of it. If a user define a void function are placed after the main function, you still have to use a function prototype, just exactly like the value function that you define. The void function does not have a return, period. It does not have that reserved word at the end. The return statement without any value is typically used to exit the function early. All right. So here's the syntax for the void function. You have a formal parameter still, very similar to the value. You have your statements in here. A function parameter are optional with this. You can leave this blank. You don't have to pass anything in there. A call to the void function is a standalone statement. Void function syntax is, this is the basic syntax. I want you to note that there is the word void here. Okay, we're going to dive into this a little bit more deeper in this thing. Here's the void. Here's the formal parameter. You notice there's this ampersand next to the data type and the variable. Data types and variables. And the function calls the actual. When you call the function name in the main, you're actually passing across as the actual parameter list, not the formal parameter. So when you pass that in, actual parameter list expression in this, okay. So here's the other thing is here's where the value parameter, a formal parameter for value receives a copy of the content of the corresponding of the actual parameter. Remember that analogy I was telling you about? If I sense a friend that goes to the alley and he knows where Dan Dow lives, for example, he's just being a reference parameter. He knows where my address is. However, this value parameter is a copy of me. It's a clone of me in that alley. You can see that the value of the parameter again is it takes up the RAM memory because you're copying it. This, on the other hand, it only costs 1 kilobyte. All right, to actually to use a reference parameter. And in this next couple of chapters, when we get into arrays, all arrays are basically reference parameter. So a formal parameter that receives the location, which is the memory address of the corresponding actual parameter. So a formal parameter that receives the location of the corresponding and memory address of the corresponding actual parameter with this thing. So this thing that we're going to talk about, when you put an ampersand next to it, that is what you're doing is whatever you're doing is a reference parameter. So this is the formal parameter that receives the location of that memory address of the actual parameter. Okay. So please keep this definition in mind as we go along with this thing, because it's going to get pretty abstracted here. However, in value parameter, if a formal parameter is a value parameter, the value parameter corresponding to the actual parameter is a copy of it. Exactly what I just said, right? The formal parameter has its own copy of the data. So again, we're doing a lot of copying. It's very, very clumsy to actually use objects and when you do this thing. Formal parameter manipulates the data stored in its own memory space with this at the same time. So here we go. This is the part that gets really fun. So if you take a look at the slide, it says if formal parameter is a reference parameter, it receives the memory address of the corresponding actual parameter. Where's the actual parameter? The actual parameter is where? Is in the body, right? We said the formal parameter is the one that's in the header. Receive the address of the actual parameter that's in the parameter in the actual function of your body. Now, during execution, to manipulate the data, change the formal parameter will change the corresponding actual parameter. So if you change the formal parameter in the parentheses, that will actually change the actual parameter in the body. Okay, so please keep both of these things in mind. You're going to see this. This is a very powerful concept that programming will have. Object-oriented programming have this. Reference parameter are useful in three ways. One is to return more than one value. Two, change the actual parameter. Three, pass an address which save memory into space and time. Please know these three bullets right here. On the exam, I have a multiple choice test question. I want to ask you which one of the following in regards to reference parameter are not useful in programming. I will list out return more than one value. Okay, so in reference parameter you can return more than one value, believe it or not. Okay, so that's a nice thing. For instance, when we get into arrays, changing the actual parameter. Where's the actual parameter? Okay, it could be in int main, it could be in the actual function body. The third bullet is passing an address which save memory. Again, this is all about memory management with it. This is what we're talking about. All right. Let me stop right here.